Thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello everyone and welcome to the Concentrator Talk call brought to you by the Oxygen Alliance. My name is Naomi Thompson and I'm currently in Lilongwe, Malawi, and I'll be your host today. Joining me are my colleagues Patani Tamandikani and Aubrey Chimkunda, and we'll also be joined by our usual technicians from OpenO2 and Sunrise. And on the panel today we have Paulina Mohosho, Masofa Mujaji, Kowinda Singh, Kelvin Saidi, Eunice Msisya, Dominic Mabanje, and Sharon Ngozo. Thank you very much for joining us. In case you're just joining us for the first time, the Concentrator Talk Call is a virtual meeting that is hosted by the Oxygen Alliance every Thursday from 2 to 3 p.m. Central African Time. And here we discuss various aspects of oxygen concentrators, maintenance, their use, and assessment. So in case you have any questions, you can send us an email through info@oxygenalliance.org, and our technicians will do their very best to respond to those questions. You should also send us your contact details in the chat so that we add you to the emailing list and that you'll be able to get notifications whenever a new material has been posted. We normally have a topic of interest, and today Sharon Ngozo will be taking us through the misuse of oxygen concentrators. So let's stay tuned together and listen into the information that we have to share. Without further ado, we jump into our questions. Our first question reads, hello, I'm a technician at Kasungu District Hospital. I do not usually work with oxygen concentrators, but I have been given a task to troubleshoot a Deverbis 515 model. When I opened up the concentrator, I discovered a black sticky material all over the covers. What happened to the concentrator and how can I remove this? So I'll ask one of our technicians to respond to that question. Okay, we have a hand from Kelvin Saidi. So Kelvin Saidi, answer that question.
Thank you, Naomi, and thank you for the question. So the Deverbis 515 covers are coated with a type of foam, and this helps in reducing the noise produced by the machine. So the graphics show the foam that is found on the Deverbis covers. So usually foam becomes sticky after some time due to a natural process called oxidation. So over time, the foam material reacts with the oxygen in the air, and this causes it to break down and become sticky. And this is particularly true for a type of foam made from polyurethane, which is commonly used in furniture cushions, mattresses, and in our case, insulation. So polyurethane foam comes, it contains chemicals called isocyanates, which can react with moisture in the air to break down the foam material. And as the foam breaks down, it releases a sticky residue, which can be unpleasant to touch and difficult to clean, as shown in the graphics. You can see a compressor which is covered in this sticky material. So working with this kind of conditions, it is it is difficult to do your job. So cleaning this residue can be a challenging task, but there are two main methods that can be effective. And one of these methods is to use a mixture of warm water and mild dish soap. So you need to dampen a clean cloth with the mixture I've mentioned above and gently rub the contaminated area. Another method is to use a solution of equal parts of white vinegar and water. So the same procedure, dampen a cloth with the solution and gently rub the contaminated area. Then use a clean cloth to wipe away the residue. Thank you. Over to you, Naomi.
Thank you very much, Kelvin, for that wonderful response. Do we have any follow-up questions or comments? Okay, seems like we have none. So we have a poll at the end of the question, and I'll ask Patani Tamandikani to launch the poll, and he'll also explain how we can access the poll. So Patani, go ahead.
All right. Thank you, Naomi. So it's time for our first call, the call. So the poll reads, have you ever come across this situation before? So the situation whereby you open a concentrator, a 515 developers to be precise, and you found that the foam inside is sticky, has stick to different parts of the concentrator. So have you ever come across this situation? Actually, we have two polls. So if you have ever come across this situation, were you successful in removing the sticky material, the sticky form in the concentrator? So I'm going to launch the two polls now. I've launched the polls and I'm going to give you time for the audience to vote. Just a reminder, to access the polls, if you're joining us from a computer, you go to the bottom right screen of your computer, bottom right corner, and there you see a activities button. Click on that. There you see a menu which has pause on the second option, and click on those and vote. If you're joining us from your mobile, you will see three dots on the bottom right corner of your screen. Click on those three dots, a menu will show up in which activities button is one of the listed options. Click on that activities button and you see pause, and then you can vote. So the votes are coming in. It looks like the majority of us have ever encountered this situation before, especially in the 515 developers concentrator, whereby we made this sticker form inside the concentrator. Of the majority that have ever come across this situation, 50% are saying that they are not successful in removing the sticky material, and another 50% they're saying they were successful in removing the sticky material. So if you are never successful in removing that sticky form, I hope the suggestion that Kelvin has explained will help you out a big deal in trying to remove that sticky material. It gets messy, especially if you don't have hand gloves to wear when fixing that 515, and you find that inside there is that sticky material. It really gets messy. So I hope you apply what Kevin has said, and good luck with that. I'll end the poll now, and over to you now.
Okay, thank you very much, Tatani, for the poll. So we move on to our next question. And our next question reads, hello, I'm a newly graduated and recruited biomedical technician at Mlambe Hospital. Part of my job requirement is to service oxygen concentrators to make sure they're functioning optimally. I have heard from a colleague about Concentrator Talk that answers questions regarding oxygen concentrators, and I would like to know from your experts the key maintenance tasks that are required for oxygen concentrators. So I'll ask one of our technicians to take the newly recruited technician through the key maintenance tasks that are supposed to be taken with oxygen concentrators. So, okay, we have a hand from Eunice Msisia. So Eunice, you take over.
Thank you very much, Naomi, for the question. So maintenance in this case refers to a set of processes and practices which aim to ensure the continuous and effective operation of an oxygen concentrator. So these medical devices require regular maintenance to ensure that they are operating in a safe and reliable manner. Maintenance should take place periodically depending on need. For example, if you are cleaning or refilling a fire bottle, please, you need to do that weekly. So I'll just outline some of the key maintenance tasks that we practice at OMNO2, and we also recommend you to do the same for your hospital, and I believe they'll be very helpful. So the first one is cleaning and filter replacement. So as we all know, oxygen concentrators draw in air from the surrounding environment, and this air can contain dust, dirt, and other contaminants that can affect the performance of the device. So regular cleaning and filter replacement is necessary to prevent these contaminants from building up and clogging the sieve beds, the compressor, and other components. This helps to maintain the efficiency and reliability of the concentrator as well as the purity of the oxygen it produces. The filters that have to be cleaned are the washable intake filters and the gross particle filters. And this should be done weekly to avoid any contamination. And non-washable gross particle filters should be replaced when they have become visibly dirty. Yeah, so another maintenance task is seedbed refilling or replacement. So the seedbeds in an oxygen concentrator are responsible for removing nitrogen from the air to produce concentrated oxygen. But over time, the seedbed can become saturated with nitrogen, reducing their efficiency. So they need to be refilled, or you can replace the whole seedbed. So seedbeds should be refilled or replaced after 5,000 accumulated hours, and you can check this on the hour meter, and then you know what to do next. So I work with my colleague Fatani, and I'll ask him also to tell us some of the maintenance tasks that we conduct here at Open02. Over to you, Fatani, if you have anything that is.
All right. Thank you, Eunice. I'll just add some two more key maintenance tasks that you can perform on oxygen concentrators, in addition to what Eunice has already pointed out. So the other maintenance task that you have to do is compressor servicing. So the compressor in an oxygen concentrator is responsible for drawing in air and compressing it for use in the concentrator, and is very necessary to ensure that the concentrator is operating at peak efficiency. So compressor servicing includes changing the cylinder sleeves, caps, gaskets, reed valves whenever they are worn out. So according to the World Health Organization, this should be done after each and every 5,000 accumulated hours. But you can do that before 4,000 accumulated hours whenever you hear that the concentrator is producing some unusual noise, like speaker sound or whatever unusual noise you hear from your concentrator. You can service your compressor. The other thing that you can do is electrical and electronic system inspection. So oxygen concentrators, they rely on a complex electrical and electronic system to operate. So and regular inspection and testing of this system is necessary to ensure its safe and reliable operation. So this, when you're doing this electrical and electronic inspection, it involves checking the power supply, control boards, sensors, and other components for any signs of wear or damage. So that's what I wanted to add on this. Thank you, and over to you, Eunice.
Thank you very much, Fatani, for that. And I believe this is going to be very helpful for you. We have just outlined some of the key maintenance tasks, but there's a lot that you can do. So regular maintenance of oxygen concentrator is very, very critical for ensuring their safe and reliable operation, as I've already said. Proper maintenance helps to prevent a lot of things such as breakdowns, and also to ensure that the concentrator is operating at peak efficiency, delivering the required amount of oxygen to patients with respiratory conditions. Thank you very much, and back to you now.
Thank you very much, Eunice and Fatani, for that wonderful response. I hope the newly recruited technician has gained a knowledge or two on how it is that they can go about maintenance of the oxygen concentrator, and welcome to the crew. So do we have any follow-up questions or comments? Okay, seems like we have none. So we have a poll at the end of the question, and I'll ask Fatani Damandigani to launch that poll. Fatani?
All right, thank you, Naomi, once again. We have a poll after this question, and the poll reads: has concentrator talk been helpful to you in conducting oxygen concentrator repairs? Has concentrator talk been helpful to you in conducting oxygen concentrator repairs? So I'd like to hear from you, the audience. I'll give you time for the audience to vote. I've already explained how you can access the polls, so go right ahead. The votes are coming in. It looks like concentrator talk is really helpful when it comes to repairs of oxygen concentrators. That's really good. The feedback is good. It keeps us motivated, and thank you for that wonderful feedback. Thank you, and over to you now.
Thank you very much, Fatani, for that poll. And as he has rightly said, we get encouraged with when we get feedback that you're following with the talk. So thank you very much to all our audience. So we move on to our next question, and it reads, hello, I'm a biomedical engineer working on an oxygen concentrator that's having trouble producing enough air with the current 50 psi compressor, which we have replaced to the initial 40 psi compressor that was damaged. The pressure drops to 0 after the valve switches to feed the sieve bed. The pressure does not rise again. However, with the initial 40 psi compressor, it was able to produce enough air to purify the oxygen, and the pressure could drop when feeding and could rise again before it feeds. Can you help me understand what is causing this and the factors that I can consider when replacing the compressor? So I'll ask one of our technicians to respond to that. The person wants to know the factors to consider when replacing a compressor in the concentrator. Okay, we have a hand from Dominic. So Dominic, you go ahead.
Thank you, Naomi. So the first step would be to identify the root cause of the issue with the current 50 psi compressor. One possibility that could be that the compressor has a low airflow capacity compared to the 40 psi compressor, and therefore is unable to supply enough air to the sieve bed. So when replacing a compressor, it's important to consider the requirements of the sieve bed. This includes the airflow capacity and the pressure needed to effectively purify the oxygen. When you are choosing a replacement compressor, it's important to evaluate the trade-offs between pressure rating and airflow capacity. A higher pressure rating does not necessarily equate to a higher airflow capacity. So it's also important to consider the overall system. This includes the capacity of the sieve bed, the size of the oxygen concentrator, and any other components that may affect the performance of the compressor. So to ensure that you select the best compressor for your oxygen concentrator, it is really advisable to consult the manufacturer's specifications and technical data sheets and replace the compressor with the suitable one. Once you have selected a replacement compressor, it's important to test it to make sure it meets the requirement of the sieve bed and the oxygen concentrator. This will help you determine if it's able to effectively produce enough air to purify the oxygen and whether or not the pressure remains stable during the operation. Thank you, and back to you, Naomi.
Thank you very much, Dominic, for that response. And we have a poll at the end of the question, so I'll ask Fatani to launch that poll.
All right, so I'm going to launch this other poll. So the poll reads, have you ever faced a situation where you had to change the compressor of a concentrator? Have you ever faced a situation where you had to change the compressor of a concentrator? I'm going to launch the poll now and give it some time so that the audience can vote. The votes are coming in. It looks like most of us have ever changed the compressor in a concentrator. And only one has never had this situation where they had to change the compressor of a concentrator. So if you've been maintaining oxygen concentrators for quite some time, you might have encountered this situation whereby the compressor, maybe the motor inside the compressor has bent windings. Of course, you can rewind the motor, but then that's an arduous task. So to avoid that, you just opt for changing the compressor. It happens sometimes. Now I'm going to end the poll and over to you now.
Okay, thank you very much, Fatani, for that poll. But also thank you, Dominic, for that response. Do we have any follow-up questions to what Dominic has responded or any comments? Seems like we have none, so we move on to our next question, and our next question reads, hello, I'm a biomedical technician working at a certain district hospital. We have an air-safe oxygen concentrator that has a broken flow meter and it can no longer be used. However, I have learned from the previous concentrator talk calls that the oxygen concentrator cannot be used without a flow meter. We have a spare flow meter from a developer's 525 oxygen concentrator. Can we use that flow meter on an air-safe oxygen concentrator? Are the flow meters interchangeable? So I'll ask one of our technicians on the panel to respond to that. So the person wants to know if they can interchange a flow meter from a 525 to an ASF oxygen concentrator. Okay, we have a hand from Paulina. So Paulina, you go ahead.
Thank you, Naomi. Indeed, a flow meter is an important component of an oxygen concentrator because it tells you how much flow of oxygen you are getting from the concentrator, and it also measures the flow in liters per minute. You cannot use the concentrator without the flow meter since you will not be able to know how much flow you are getting. So different flow meters come with different flow rates. Most oxygen concentrator flow meters come with 5 liter per minute, 10 liter per minute, or 15 liter per minute. You also need to understand that flow meters are specifically designed for specific models of oxygen concentrators and will work well with those models only. Most flow meters designed for a different concentrator model, but with the same flow rate, such as the SF flow meter and the DeVilbiss 525 flow meter that you have. These are not interchangeable with each other, mainly because of the difference in positioning of the inlet and the outlet port and the differences in the pressure at which they were calibrated. However, flow meters designed for a different concentrator model, but with the same flow rate, are interchangeable only when indicated to have been calibrated at the same pressure and have the same footprint. So they would need to have the same positioning and the shape of the inlet outlet ports. If you interchange the flow meters, then you will not be able to get the desired results. Sometimes you might see the ball rises in the flow meter, but you will not be able to get the right flow rate. So make sure that you only use the flow meter of the same model to avoid any problems. Thank you, Naomi.
Thank you very much, Paulina, for that response. Do we have any follow-up questions or comments to what Paulina has responded? Okay, seems like we have none, but we have gotten an idea or two that it is going to be hard for us to use a flow meter from a 525 with an ASF, so we better find our spare parts right. So we move on to our next question, and the question reads, hello, I'm working on a DeVilbiss 525 concentrator. After troubleshooting, I found out that the transformer was 40. I salvaged another transformer from of the same voltage output as the damaged one in the workshop. Can I use this as a replacement? So I'll ask one of our technicians on the panel to respond to that question. Okay, we have a hand from Kowinda, so Kowinda will be answering that question.
Thanks, Naomi, for the question. Replacing a transformer with another of the same voltage rating is not always straightforward solution because transformers are designed work within a specific electrical system and to meet specific requirements which go beyond just the voltage ratings. So one important factor to consider is the current capacity or the ampacity of the transformer. So as we can see the picture of the transformer in the presentation. So the ampacity determines the maximum current that a transformer can handle, and it must be sufficient to meet the demands of the electrical system it is serving. A transformer with a different current capacity from the original one, which not may be able to supply the required current, leading to potential damage to the transformer and the connecting equipment. Another important factor is the impedance of the transformer, which affects the stability of the electrical system and the voltage regulation of the transformer. Different transformers can have different impedances, and using a transformer with a different impedance can result in unstable operation and poor voltage regulation. Finally, transformers can have different mounting arrangements, connections, and the terminal configuration also. So these physical differences can make it difficult to simply replace one transformer with another. Even if the voltage and the current ratings are same, for example, in your case with the 5 to 5 concentrator, if the transformer is bigger than the original, it might not be get mounted properly on the board, and you might even face difficulties closing the concentrator. So in conclusion, replacing a transformer with another of the same voltage rating is not a straightforward solution and must be done with caution. It is important to consider factors such as current, capacity, impedance, and physical differences to ensure the replacement transformer is compatible with the electrical system and meet the specific requirements of the application. Thank you.
Thank you very much, Koinda, for that wonderful response. Do we have any follow-up questions or comments to what Koinda has just explained? Okay, seems like we have none. So we have another poll at the end of the question. So I'll ask Fatani to launch that poll. Fatani, over to you.
All right, I'm going to launch another poll, and the poll reads: have you ever replaced a transformer with another from a different concentrator? Have you ever replaced a transformer with another from a different concentrator? I have launched the poll and I'm going to give you some time so that the audience can vote. So let's go ahead and vote. All right, so the votes are coming in. It looks like the majority of us have never ever replaced a transformer with another from a different concentrator. So in case in future you encounter this situation, just follow through what Kuinda has said. He's talked about the current rating, the impedance, and the likes. So you have to put that into consideration when replacing a transformer. Make sure that they have the same rating, they have the same impedances. Otherwise, you're going to disturb your system or maybe even burn out your concentrator. So just follow through what Winda said. I'm going to end the poll now and over to you, Naomi.
Thank you very much, Fatani, for that poll. Just a quick reminder before we move on to our topic of interest. If you have not yet shared with us your contact details, please do so in the chat that we'll be able to add you to the emailing list for you to get notifications of the activities that are taking place at the Oxygen Alliance. In case you have any questions, you can simply paste them in the chat and I'll read them out, or you raise up your hand and come off mute and ask your questions, and our technicians will do their very best to respond to those questions. So right now, we'll take a diversion into our topic of interest, and Sharon Gozo will be taking us through some of the misuses of oxygen concentrators. So let's stay tuned. Sharon Gozo, you take over the floor.
Thank you very much, Naomi. So, as Naomi has already said, today we'll be talking about the misuse of oxygen concentrators. So, an oxygen concentrator is a vital machine that delivers oxygen to patients, and it takes in air from the surrounding and filters it to give out oxygen. So, just like any other machine, concentrators need to be taken care of and appropriately used to work effectively and to elongate the lifespan. So when a concentrator is not appropriately used, it raises an alarm on some occasions, and at times it might not deliver the required oxygen purity as expected. So as the OpenO2 team, we have moved around in different hospitals and we have seen some of the misuse, how some parts of the concentrators are being used, and some of those are what we're going to talk about today. So there are a lot of misuse that we have found, but today we'll just talk about a few of them. So we'll talk about the flow meter and the humidifier bottles, how these two are being misused and how can we use them properly. So firstly, we'll start with the flow meter. So the flow meter is attached to the concentrator and it is used to set the rate at which oxygen is being delivered to a patient. And it is measured, the flow on the flow meter is measured in liters per minute. So as you can see on the graphics show two flow meters. The other one shows the parts of the flow meter. So there are different parts that have been labeled, but we'll focus on the flow tube scale, the control knob, and the flow meter ball. So the flow meter tube scale is labeled in liters per minute. So we have various models of concentrators and their flow meter scales differ. So we have some that range from 0 to 3 liters per minute, others from 0 to 5 liters per minute, others 0 to 8 liters per minute, or others 0 to 10 liters per minute. I know there are some that go up to 15 liters per minute. So one thing to take note of is you cannot interchange the flow meter of different models of concentrators. So this has already been pointed before. So Porina mentioned it as she was answering one of the questions. So most flow meters have the lead line at the top of their flow tube scale. So the lead line represents 0.5 liters per minute. So if your maximum capacity is 5 liters per minute, this means that the lead line is at 5.5 liters per minute. So when adjusting the flow meter bore on a concentrator that is on a patient, you should not go beyond that line. So some concentrators raise an alarm when the bore goes beyond the lead line, accompanied with a low purity LED. More flow than what the flow meter is calibrated. For example, using a 5 liters concentrator to give out 7 liters or 8 liters or more. So when the bore goes beyond 5 liters per minute, which is beyond the lead line, you surely get much flow, but it is unregulated. So you're not sure if you're giving out 7 liters or more than that. So this dilutes the oxygen purity. So if you're getting 95.6% at 5 liters per minute, you won't get the same purity when the bore goes beyond the lead line. So this dilutes the oxygen and the purity drops drastically. Hence the low purity LED and the alarm. So the best way to solve this is to use a 5-liter concentrator when you need to deliver a flow of 5 liters per minute or less to a patient. If you need more than 5 liters, if let's say you have a patient that needs more than 5 liters, then you have to use an 8-liter or a 10-liter concentrator. Or you can combine two concentrators. So you can combine two 5 liters concentrators, then you connect the patient output with a T connector. From this, you can get purity more than 5. Then you just adjust the two concentrators to the flow that you need. Then you connect it to the patient. So as you can see on the graphics, we have two concentrators that are joined by a T connector. So moving forward, another inappropriate thing is using a concentrator without a needle valve. So sometimes you might have only the knob missing, and sometimes the knob and the needle valve are not there, as you can see in the graphics. So the control knob is connected to the needle valve of the flow meter. So in cases where only the knob is missing, one might try to seal the flow meter opening with plaster to keep the bore inside, but this is not appropriate. So even though you have the bore inside, you're still giving out an unregulated oxygen flow because you're not controlling the bore anymore. So if you don't know the flow of at which oxygen is being delivered, then that's not good, and the purity will be affected as well. So you also have a risk of having leakages, as it is not guaranteed that whatever you're using to seal, which is like for this case the plaster, you haven't completely sealed the leakage. So in cases where you have both the needle valve and the bore missing, which is commonly in concentrators that have dual flow meters. So if one flow meter has a knob and it's working perfectly, but the other doesn't have a needle valve, or it's missing the needle valve and the bore, if you switch on the concentrator, oxygen will leak from the 40 flow meter automatically, since it is providing a path without any restriction. So using the functional flow meter in this case doesn't help in delivering oxygen because purity is already affected. So to solve this issue, the flow meter has to be replaced with a new one, which is identical to the 41. As we have already heard that you cannot interchange from a different model of a concentrator to another model. So if the bore and the needle valve can be replaced, that would be an easy and cheap fix also. So if they cannot be replaced, then you get an identical one and replace it. If the concentrator is in urgent need and it will take days to purchase another flow meter, then the maintenance team has to open the concentrator up and close the pipe that supplies oxygen to the damaged flow meter. So this can be done using a cable tie. So as you can see on the graphics, we have a photo that is showing a pipe. So this is a J5 concentrator that has 2 flow meters. So one flow meter was damaged. So all we had to do is open it up and tie the pipe that is providing oxygen to the damaged flow meter. So this will help because it will prevent oxygen from being wasted through that damaged flow meter. So when the new flow meter is purchased, the tail up can be removed and the pipe connected back to the flow meter. And now the concentrator will be in perfect condition. The second thing we'll talk about is the humidifier bottles. So these are used to help moisturize oxygen for comfortable breathing by the patient. So this needs to be taken care of and used appropriately. So the following are the misuse, and these practices are discouraged. So the first is using distilled water in the humidifier bottle for longer periods of time. So this gives room for microbial growth and debris or mineral buildup at the bottom of the bottle, which ends up getting stuck or closing the diffuser or filter. So this restricts the flow of oxygen to be delivered to the patient. The other thing is using bottles with threads that don't match that of the concentrators patient output. So take note that we have some bottles that have the metal inlet nut, some that have the plastic inlet nut. So this, if we're using these bottles on concentrators that they don't match, this will eventually damage the bottle as you'll be forcing the bottle to fit on threads that do not match. So it has to be taken note that there are some bottles you can interchange within models, but some you cannot. Another thing is not tightly closing the humidifier bottle when connecting to the concentrator, which gives room for leakages. So this results in oxygen escaping to the surrounding and little amount of oxygen is delivered to the patient. Another thing to take note that we have seen is the plastering of the humidifier bottle lip valve. So the lip valve is used to bleed off excess pressure that has been built up inside the bottle. So from the graphics, you can see a masked lip valve. So excess pressure will normally be caused by kinks in the pipe going to the nasal cannula or face mask of the patient. So if there's no space or path for the oxygen to pass through, then it accumulates in the bottle. And that excess pressure in the bottle has to be relieved through the valve. Another misuse is overfilling of humidifier bottles. So these are scenarios where water is filled in the bottle past the maximum level. So this can result in water getting into the nasal cannula or face mask. So how can all this be solved? So it is recommended to use distilled water in the humidifier bottles. So only use distilled water in the humidifier bottles. I know there are some times where distilled water is not available at a facility or at a hospital and people use tap water. So if you're using tap water, make sure you change it every day. Don't let water stay in the humidifier bottles for long. So the water in the bottle has to be changed regularly. It is advised for the water to be changed for every patient that is connected to the concentrator. So this helps to prevent the transmission of diseases from one patient to the other. The other thing is close the bottle tightly before connecting it to the concentrator. So check the leakages on the bottle You have to check, that's when you have connected the bottle. Before connecting to the patient, you have to check for leakages on the bottle connector to the concentrator and the bottle itself with its cover. So all you have to do is, once you have made your connections, you have closed the bottle tightly and you have connected it to the concentrator, switch on your concentrator. When it's switched on, try to close the oxygen outlet. When you close it, if you've tightened everything tightly, then we expect the leaf valve to pop after a few seconds. If the leaf valve is not popping after a few seconds, it means oxygen is leaking from somewhere. So you have to check for those leakages and make sure it is tightly closed. And the last thing to note on humidifier bottles is when filling the bottle, don't exceed the maximum level indicator. So the bottle shows you the minimum and the maximum. So when you're filling water, don't exceed the maximum level. Some other things to note when a concentrator is in use is make sure the concentrator is at least 2 feet from the wall and other obstructing objects. So we have to remember that the concentrator has a compressor which lands without stopping, so it's compressing the air. So as this is happening, it gets cold, it gets hot. So we know that we have fans in the concentrator that cool off the compressor. So some of the fans are installed inside so that they can remove hot air from inside to the outside, and some are positioned in a way that they take in cool air from outside into the concentrator. So for all these processes to happen perfectly, there's supposed to be room around the concentrator for the air circulation. So if you don't have that space, then it happens that your concentrator heats up, and this affects the purity of the concentrator in overload. So make sure that you have enough space for air circulation around your concentrator when it's on a patient. And one thing to take note of is the concentrator's power cord. So make sure it is long enough to accommodate the space for the air circulation. So don't use a small power cord, because sometimes maybe it might be close to the wall just because the power cord is small. Make sure you have a power cord that is long enough to accommodate the space for the air circulation. Another thing that I have to point out that has already been said is the cleaning of the gross particle filters. So you have to periodically be checking these, and if they are dirty, make sure that they are cleaned, air dried, and then put back into the concentrator. Never use a concentrator without filters, as it is not healthy for the concentrator. And for it to function perfectly well and deliver the oxygen that we are looking for, it needs to have the filters. So reaching at this point, this is the end of topic of interest. Thank you, and over to you now.
Thank you very much, Sharon Gozo, for that wonderful topic of interest and sharing that knowledge. Do we have any follow-up questions or comments to what Sharon has just explained? Okay, seems like we have none, so we will move back to our questions, and our next question reads, hello, I'm a biomedical intern working on a concentrator whose reset switch keeps tripping. After troubleshooting, I found out that some wires inside the machine were exposed, and this was causing a short circuit. Can I use plastic bag to cover these exposed wires? So I'll ask one of our technicians on the panel to respond as to whether the person can use plastic bag to cover the exposed wires. Okay, we have a hand from Masofa. So Masofa, you go ahead.
Thank you, Naomi. When you are working with exposed wires, it is crucial to ensure the safety of both people and the machine. So while it may be tempting to cover the exposed wire with the material that you have, like the plastic, for example, it is crucial to think about whether this strategy is secure and appropriate. It's not a good idea to use a plastic bag to cover a machine exposed wires, as this could potentially come to a risk and concerns. Covering exposed wires correctly is important to ensure safety and prevent electrical hazard. Here are some general guidelines regarding international standard for covering exposed wires. First one, choose the appropriate wire covering material based on the type and size of the wire being covered. Common materials include heat shrink tubes, wire loom, and electrical tape, which is an insulation tape. The covering material should be rated for the voltage and temperature of the wire being covered. The covering material should be able to withstand environmental factors such as moisture, heat, and ultraviolet exposure. The covering material should be properly secured and tightly fit to the wire to prevent any movement or slipping. The covering material should be applied in a continuous or an uniform manner to prevent any exposed area. While improvising with available materials can be a tempting solution for covering exposed electrical wires, using a plastic bag as insulation is not recommended at all. Plastic bags are not designed or rated for electrical insulation and can pose a significant risk of electrical shock or fire. They may also deteriorate over time and expose the wire, causing further safety hazard. Improvising with materials not intended for electrical applications can result in dangerous consequences and should be avoided. Thank you.
Thank you very much, Masofa, for that wonderful response. Do we have any questions or comments to what he has explained? Okay, seems like we have none. So we have another poll at the end of this question. So I'll ask Fatani once again to launch that poll. So Fatani, you go ahead.
Thank you, Naomi. So I'm going to launch another poll, and the poll reads, have we ever encountered a scenario where the reset switch kept on tripping? Have you ever encountered a scenario where the reset switch kept on tripping? So I've launched the poll now, and I'm going to give it some time so that the audience can vote. I've already explained how we can access the polls, so let's go ahead and vote. All right, the votes are coming in, and it's split 50-50. 50% of us have never encountered this situation, and 50 have ever come across a concentrator whose reset switch kept on tripping. It happens a lot, especially when there is a loose electrical connection inside two wires touching the reset switch. It's a protective mechanism, just like a fuse. So it will trip until that problem has been fixed. Keep on tripping until that problem has been fixed. You turn on the concentrator. If some wires are touching inside, you see that the reset switch has tripped. You turn off, you push the reset switch in, you turn on the concentrator again, you find that the reset switch has tripped again. So this is just a protective mechanism that oxygen concentrators incorporate. Some concentrators do not have this. I've encountered one Chinese model concentrator that did not have a reset switch, just had a fuse, but those are Chinese. I'm going to end the poll now, and over to you now.
Thank you very much, Fatani, for that poll. And looking at our time, seems like we're at the end of our call today. Hope to see you again next week, same time from 2 to 3 p.m. Central African Time, where the Oxygen Alliance will be hosting the Concentrator Talk Call again. Just a quick reminder before we leave, in case you have any questions to do with your oxygen concentrator, maintenance, assessment, and use, you can send us an email through info@oxygenalliance.org, and our technicians will do their very best to respond to those questions. We have a website, www.oxygenalliance.org, where you can find all the work that the Oxygen Alliance does. We also have a YouTube channel where we post recordings of the past calls, but also videos to do with oxygen concentrators, maintenance, assessment, and use. So you can visit our channel, subscribe, and also hit the notifications bell that you get notified whenever it is that we have posted new material. I wish you a lovely week, and bye for now.